Hello students, so today we are going to continue this portion, that is continuity. So in this chapter we are going to deal with continuity and differentiability. Okay, so in today's session we are going to start with continuity. So let's start. So see here, what we are going to see in the continuity part. See very carefully everyone. uh, when we can say a function is going to be continuous, या हम कब कह सकते हैं एक फंक्शन हमारा continuous होगा. So a function fx is said to be continuous at x equal to a if fx is defined in the neighborhood of a and limit x tends to a, f of x is equal to f. Okay, like हम तभी किसी फंक्शन को कॉन्टिन्यूअस बोल सकते हैं जब वो फंक्शन अपने नेबरहुड पॉइंट्स में मींस LHL और RHL लेफ्ट हैंड लिमिट एंड RHL राइट हैंड लिमिट में वो कॉन्टिन्यूअस है. जस्ट लाइक सपोज मुझे आपके बारे में पता करना है, मुझे किसी इंसान के मुझे किसी पर्सन के बारे में पता करना है. सो मुझे क्या करना पड़ेगा, मैं पहले उसके पेरेंट्स से उसके बारे में बात करूंगा, देन आई विल डिस्कस विद हिज फ्रेंड और हर फ्रेंड्स और आई विल डिस्कस विद हिज नेबर. सो अगर सभी लोग यही बोलेंगे कि ये एक अच्छा आदमी है, एक अच्छा लड़का है, सो पेरेंट्स डेफिनेटली पेरेंट्स आर गोइंग टू से कि हमारा बच्चा बहुत अच्छा है. फ्रेंड्स आर आल्सो गोइंग टू से यस हमारा जो फ्रेंड है ही इज वेरी गुड. अगर हमें सेम आंसर नेबर से भी मिल रहा है तो आई कैन अंडरस्टैंड दैट हाँ सच में आप अच्छे हैं. सेम काइंड ऑफ टैक्टिक्स वी आर यूजिंग हियर कि जब LHL भी यही बोले कि फंक्शन हमारा कॉन्टिन्यूअस है, RHL में भी हमें सेम वैल्यू मिले और जब हम फंक्शन की वैल्यू पुट करें तो भी हमें सेम वैल्यू मिले, then in that situation we can say the function is going to be continuous. Okay, so for that reason, in other words, f is continuous at x equal to a. Here the limit of f, the limit of the function at a is equal to the value of function at a. So this is the important stuff. It is representing actually LHL and RHL combinedly. ठीक है, सो यहाँ पर LHL and RHL दोनों को कॉम्बिनेशन है और ये सारी की सारी वैल्यू हमें f of a की इक्वल होनी चाहिए. ठीक है, ओके, लेट्स सी द नेक्स्ट स्लाइड, दिस वन. Let f be a function. So what we are going to discuss in this continuity of a function at a given point. So let f be a function defined in a neighborhood of a point a. The function f is said to be left continuous at a when we take the lower limit, right continuous at a when we take the upper limit, and they both have to equal to f. That is we have already discussed in the last slide. ठीक है, अब if the function f is continuous at a, f is both left continuous as well as right continuous. ये हमें पता है पहले से. इसका मतलब है कि हमारे जो लिमिट है x tends to a fx, it is going to be equal to f of a. It means LHL is equal to RHL is equal to f. So keep this thing in your mind. ठीक है, कि अगर हमें कोई भी फंक्शन को चेक करना है कि वो कॉन्टिन्यूअस है या नहीं है, so we will go with LHL, then RHL, then the value of the function at the given point. ठीक है, if all these values are equal, then we will say yes, function is going to be continuous. Okay, now let's see further. Here I am going to discuss what are the situation when the function is like continuous or not continuous, something like that. So the function fx is discontinuous at x equal to a. This is one of the condition when fx is not defined, means जब हमारा function x equal to a पे defined ही नहीं है. Just like 1 upon x, if we put x equal to 0, the 1 upon 0 will become not defined, something like that. ठीक है, यहाँ पे आप ग्राफ ही देख रहे हैं. यहाँ पे if we are moving towards left or from here to right, this is, and there is a gap here. Okay, so at x equal to a, there is no function, there is no graph there, then we will say the function is not defined. ठीक है, The next condition is if limit x tends to a, fx does not exist, means जो भी हमने लिमिट ली है, LHL और RHL लिया है, वो एग्जिस्ट ही नहीं कर रही है फंक्शन में, ठीक है। फर्दर limit x tends to a, fx exists but this value is not equal to fa, means LHL और RHL की वैल्यू आ तो रही है बट वो f of a के इक्वल नहीं है, ठीक है। So there are three situations. I will discuss all of these situations one by one. Okay, let's see. So this is one of the condition. The function fx is not defined at x equal to a. So if you see here, like graph is continuously proceeding in this direction, but at this point we can see a hole. Okay. After that again graph is continuous. But we know that at x equal to a there is no space, like there is no graph. That's why we will say कि x equal to a पर हमारा फंक्शन क्या है, डिफाइंड नहीं है। ओके, लेट्स सी द नेक्स्ट कंडीशन, दैट इज दिस वन, limit x tends to a, fx does not exist, means see graph is continuous till this point and here we are including this one, but जब हम दूसरी वैल्यू पे पहुंचे so यहां पे graph is starting from here and this value is not considerable, means graph finally यहां तक पहुंच गया but further graph कहां से start हुआ, यहां से, so there is a gap और इस पर्टिकुलर गैप के लिए वी डोंट हैव एनी वैल्यूज। ओके, सो लिमिट x टेंड्स टू a does not exist because we don't have any idea about like how the function behave in this manner. Understood? Okay, let's see the third point. Third point is like limit x tends to a exists but the value of what not equal to f of it, means limit are there but the value of limit are not equal to f of it. So if you see here ग्राफ यहां पे कॉन्टिन्यूसली इंक्रीज होता जा रहा है बट यहां पे एक होल आ गया है और जो वैल्यू हमें यहां पे मिलनी चाहिए थी दैट इज देयर। ओके, सो देयर इज अगेन गैप, मींस जो भी हमारी f of a की वैल्यू है दैट इज नॉट इक्वल टू लिमिट्स, दिस टाइम वैल्यू इज डिफाइंड बट हमारी LHL और RHL की वैल्यू यहां पे इक्वल नहीं है FA के। सो दिस इज द थर्ड सिचुएशन। डन? ओके, लेट्स सी द नेक्स्ट सिनेरियो। नाउ continuity of a function on its set. So this is very basic once again. Let's see here. If you see this one, a function f defined on a set S is said to be continuous on the given set S if it is continuous at each point on S. What is this? Set. Continuity and open interval. So what is the meaning of open interval? Like suppose the graph is like this. So here we are not going to consider these 2 points. Like suppose this is A and suppose this is B, so we don't have to consider A and B. Okay, so a function fx is said to be continuous open interval a comma b when fx is continuous at each point between a and b. Okay, similarly it means limit x tends to c minus fx is equal to limit x tends to c plus fx is equal to that particular point. Suppose I have taken this point, ठीक है, और यहां पे एक चीज और ध्यान रखनी है, here we have to check RHL and here we have to check LHL. Okay, so this thing you have to keep in your mind when we are discussing about the which part, open interval. Let's see the next one, that is going to be closed interval. So in the closed interval, what is the difference? You can see here a function defined on the closed interval AB is said to be continuous on AB if function is continuous at every point of AB, that is limit x tends to c fx is equal to f of c. Means suppose again we are having this function but this time we are including these two values. Okay, we are including these two values. So suppose this is A and this is B. Done. Now हम कब कहेंगे कि ये फंक्शन राइट कॉन्टिन्यूअस है? f is right continuous at a, limit x tends to a plus f of x is f of a, and f is left continuous at b when limit x tends to b minus. B minus means this side, a plus means that side. Means for a plus we have to move in this direction, for b minus we have to move in this direction. ठीक है? I guess you have understood everything. Okay, let's see the next stuff. Now, the graph of a continuous function on the interval, like which kind of interval? Closed interval, exhibits no abrupt jumps or holes or breaks. Means अगर हमें अचानक से suddenly we are seeing jump, break or something like that, then at that same time we will say the function is not continuous. It can be drawn without lifting the pen. Like if I am able to draw any kind of graph without lifting the pen, then we will say it's the kind of continuous function forming a smooth connected curve. Okay, smooth connected curve. Every point on the graph correspond to a value of the function, ensuring a seamless and uninterrupted representation. Understood? Now, a function is said to be continuous everywhere if it is continuous on the entire real numbers. So in that direction we will say it is minus infinity to infinity. Okay? Okay, let's see the next. Now this is very basic question I have taken for you people. Like this is from IIT JEE 2003. So they are actually asking here, what is the question here? Let this bracket is denoting the greatest integer function GIF, that is f of x is tan square x. So which option we are going to take, it is going to be correct. So definitely if you go with LHL, or we have to check for RHL also, as well as we have to check for f of a also. Okay, so let's check for f of a. If you take tan square 0, definitely you will end with 0. So f of a you will get 0. Understood? If you take x tends to 0 minus, if you go with x tends to 0 minus, this is going to become tan square what? X minus h, and for RHL it will become tan square x plus h. But again we know that h is, if you are going to take h, then x tends to 0. So again in the same situation, LHS is also going to become 0 because tan square x plus h, tan square x minus h. So here also it will be 0. So we can say that LHL is equal to RHL equal to f of a. So in this case we can see LHL equal to RHL equal to f of a. So definitely here the function is going to be continuous at x equal to 0. Okay. Limit x tends to 0, fx does not exist. No, this is wrong. F of x is not differentiable. No, okay. F dash 0 is 1. If you go with that, no, it is not correct. So we are going to take only one option, that is f of x is continuous at x equal to 0. Okay. Now, let's see the next one. Okay, so I have taken some some standard function so that where they are actually continuous or not. So here you can see, like if x is equal to c, like if you take any random constant value, so what will happen here? This is going to be continuous for all the real numbers. If you take any variable like fx is equal to x, then it will be continuous for all the numbers. Means we can take any number. Okay. Now fx is equal to x to the power n. So here we can take any number, any real number. So definitely real. Here there is this issue. If you take x equal to 0, then this is not going to happen. So that's why we have excluded 0 here. Fx equal to root x, yes, it is correct, but we can't take any negative value because we know that negative value, it is not going to make you continuous. Okay, so definitely we will go with 0 to infinity including 0. F of x e to the power x, we are free to take any value as x. Okay, so definitely real part. Okay, so for this one, e to the power x, all the real values is going to happen for this one. Now let's see the next very basic one. If you see here, f of x is equal to a to the power x, where a is greater than 0. अब हमारे पास यहाँ पे ध्यान से देखना है, a is greater than 0, ऐसा क्यों लिखा? क्योंकि सपोज इफ आई टेक एनी नेगेटिव वैल्यू लाइक -2 और हमने यहाँ पे x की वैल्यू भी माइनस में ले ली, सो डेफिनेटली वी विल एंड अप विद अंडर रूट नेगेटिव साइन. सो दैट्स रीजन we have written a is greater than 0. ठीक है. Now let's see this log x. So we know that 0 to infinity excluding 0 and infinity. Sin x हमें सभी को पता है, sin x is continuous on all the real numbers. Definitely for cos x also all the real numbers. For tan x all the odd multiple of pi by 2. We are not going to contribute them. Okay, so yes. And for sin inverse x -1 to 1. Similarly, for the cos inverse x -1 to 1, tan inverse x all the real numbers, mod x. Here if you see mod x, what is mod x? Like we are free to take any negative or positive value, but because of mod we will end up with a real. So that's why here we will see it is r. What is this? This is GIF, greater integer function, greatest integer function. So we can't take integer here. Okay, we can't take integer here. If you see this one, so actually this is FPF, fractional part function. So it is going to become x minus GIF. Okay, so again because we can see this is there, this GIF is already there, so again we can say the same where this function is not continuous, again the same stuff is going to copy in this one also. Okay, now what is signum function? Signum function, you know, like signum function will give you 1 if x is greater than 1 or 0, we can say. Signum function is going to give you -1 if x is smaller than 0, and signum function is going to give you 0 if function value is 0. So that's why we are excluding here 0. Now let's see our another stuff. Every polynomial function is continuous. Remember this, either it is quadratic, cubic, biquadratic, whatever it is, so it is going to be continuous. A rational algebraic function that is in the form of fx is equal to px upon qx, where qx should not be equal to 0, is continuous in its domain of definition. Okay, so r minus x belongs to R, where qx is not allowed to become 0, where px and qx are two polynomials. Okay, now an irrational function is continuous in its domain of definition. An irrational function is continuous in its domain of definition. It is quite simple. Now let's start with our very basic question. What is the question here? What is the set of discontinuous points of the function fx is equal to gi of x? So if you remember, we have seen already this stuff, that the function is going to be discontinuous for all integers. So what we will write? For all integers, function fx is equal to gif of x will be discontinuous. Okay, so very basic this one. Now let me discuss one more question. This, what this question is saying, let fx is equal to e to the power tan x minus ex plus log sec x plus tan x minus x upon tan x minus x be a continuous function. Okay, then at x equal to 0, the value f0 we have to find. See, so in this kind of question, if you see very carefully, if you put 0, okay, if you put 0 here, tan 0, e to the power 0, 1, e to the power 0, again 1, 1 minus 1, 0, log sec 0, 1, tan 0, 0, log 1, what? log 1 will be 0 minus log 1. So here what is going to happen, we will end with 0, the numerator will become entirely 0, and tan x minus x, tan 0 minus 0, so again 0 upon 0 format. So for this kind of question, we know like there are different methods, but I'm going to use L'Hospital route. So how to deal with this kind of question? Okay, let's see. So at f0, the function is giving you 0 upon 0 format. So I'm going to go with f dash x. Okay. So what is f dash x? Means we are going to use L'Hospital rule. Okay. So I'm going to write here. So by using L'Hospital rule. Okay. Now, so what is the meaning of L'Hospital rule? We have to go with d by dx of numerator separately and denominator separately. So it is going to become e to the power 10x dot tan x will give you sec square x minus e to the power x will remain same, e to the power x plus log because of log x 1 upon x. So here it will become 1 upon sec x plus tan x dot, because of chain rule, now sec x plus tan x, dy by dx of sec x plus tan x. So it is going to give you sec x will become sec x dot tan x plus tan x will become sec square x. Okay, and this will become minus 1 divided by tan x, again this will become sec square x minus. Now we got the value of f dash x. Now if you see properly, if you see here, we can take sec x common. Okay, so in the next step, f dash x e to the power tan x dot sec square x minus e to the power x plus sec x we can take common. So this is going to become tan x plus sec x divided by sec x plus tan. We can cancel this one and here it will be 1. Now this is going to become sec square x. Okay. Now if you see properly, so f dash x, what is the final f dash x? We will get e to the power tan x dot sec square x minus e to the power x plus sec x minus 1 divided by sec square x minus 1. If you see, if you put 0 here, tan 0 e to the power 0, what? 1, sec 0 1, 1 into 1 1, 1 minus 1 0, again sec 0 1, 1 minus 1 0, again 0 upon 0 format. So whenever again we are repeating 0 upon 0 format, it means again we have to move with double differentiation. Okay, so I'm just going to double differentiate this part. Okay, let me remove this entire stuff, then we will move further. So here if you see double differentiation, so yeah, f double dash x e to the power, here we have to use first second. If you know first second UV formula, first into second, so e to the power tan x dot sec square x, first into second, sec square x will give you what? 2 sec x. First of all it will give you sec x. Now chain rule, sec x will give you sec x dot tan x. This is first into second plus second into first means sec square x dot e to the power tan x dot tan x divided dx of tan x, again we will get sec square x. Okay, so this portion done. Now d by dx of minus e to the power x, it will remain same. D by dx of sec x, you know already what is going to happen, sec x dot tan x minus 1 is there, so it's a constant value, so we are going to write 0 directly. Now here sec square x, again you know already what happened, 2 sec x dot sec x will give you sec x dot tan x minus 1. Here also it will become 0. Now let me solve further here. Let me simplify this value. If we are again ending with 0.0 format, we will again going with triple differentiation. So f double dash x is equal to e to the power tan x 2 sec x, it will become 1 upon cos x, 1 upon cos x, tan x is what? Sin x upon cos x. So we can write 2 sin x upon cos cube x. Okay, here also e to the power tan x will be there. Sec square x, this will become cos 4x after, like, the reciprocation, and this will become same, and sec x upon tan x, sec x is nothing, 1 upon cos x, sin x upon cos x, so we will end up with sin x upon cos square x. Okay, now divided by the same stuff, 2 sec x tan x, the same stuff here, so we will end up with 2 sin x upon cos cube x. Now we can see, like, everywhere we are having denominator as cos everywhere. So what I am going to do, I am going to multiply cos 4x here and cos 4x here. Okay, just multiply this one. So this will become f double dash x is equal to, see carefully, cos cube x cos 4x, one cancel. Okay, so this will become e to the power tan x dot sin 2x. Okay, cos cube x cos 4x, one cos x will be there, associate with this 2 sin x cos x will become sin 2x plus e to the power tan x, because there is already cos 4x, multiply will cancel each other. Here it will become e to the power x cos 4x plus, it is here only, plus sin x cos square x cos 4x, so it will give you cos square x. Now done this part. Now see here, this will again become 2 cos cube x cancel out, 2 sin x cos x, 2 sin x cos x, and we know that what is 2 sin x cos x? It is nothing, it is sin 2x. Now, so we have ended up with the f double dash x. Again, if you put f x value 0, so 0, it will be 0, sin is there, so this entire will become 0, e to the power 0, 1, 1 minus 1, 1 minus 1, because this is also 1, 1 minus 1, 0, this is also 0, so 0 upon 0, again we are not going to end with the answer. It means again we have to move with f triple dash x. Okay, so let me solve the last part, that is f triple dash x. Okay, so see here how we are going to, because it is little bit more complicated kind of problem. Let's see. So here we have to use uv, here we have to use uv, and here also we have to use uv. Let's start. First, tan x dot first into second, so it will give you 2 cos 2x. Okay, sin 2x will give you cos 2x, then 2x will give you 2x. This is first into second, done. Second into first, so second into first means sin 2x dot e to the power tan x, it will remain same, dot tan x is there, so again sec square x. Okay, plus e to the power tan x, again e to the power tan x dot sec square x, you know how, minus first into second, but open this bracket, otherwise you will get confused. Okay, so first into second, it will become e to the power x 4 cos cube x. Now cos x will give you minus sin x plus second into first means cos 4x dot e to the power x, it will remain same, so no issue there. Now the last part, first into second. Okay, so first into second will be sin x, sin x only is there, dot cos square x will be what, 2 cos x dot cos x, again it will give you minus sin x plus second into first, so cos square x dot d by dx of sin x, it will be cos x. Okay. Now this entire value is going to divided by sin 2x divided by dx of sin 2x, it will become 2 cos 2x. Now I guess everything is clear in front of you. Okay. Now what is going to happen here? Now let's put f triple dash 0. Okay. Now this is going to become e to the power 0 0. This is going to become e to the power 0 1 dot 2 dot 1. So 1 dot 2 dot 1, it is nothing, it is 2 actually, plus because of sine, you know, sine 2 into 0, because we have letting x equal to value 0, so sine 2 into 0 sine 0, because of that this entire term will become 0, plus e to the power tan 0 0 e to the power 0 sec 0 1 into 1 1 will be there, minus, because of that this will become positive. Okay, e to the power x, but here you know this is sine x, so because of sine 0 everything will become 0, and this is negative cos 4x, so it is cos 0 to the power 4 1 e to the power 0 1 dot 1, but this time it is negative. Now again if you see this term, again there is a presence of sine 0 is going to give you 0 only, so I am going to write 0. Okay, now the last term cos 0 whole square cos 0, so it is going to give you again 1, and in the denominator it is 2 into cos 2 into 0 cos 0, cos 0 is 1, 2 into 1 it is 2. So now we can say it is, we can cancel here, so finally we can say that f triple dash 0, it is going to be 3 by 2. This is our final. So I hope whatever I have discussed in this question you have understood. Okay, thank you so much. Okay, let me thank you once again. We will continue in the next class. Thank you.